Sir, the 2 hours that we are going to get, is it including the uploading time as well?
Yes. I may add a little bit extra. Yeah, I'll give you enough time. Don't worry about that. I may add a little extra time too for the logistical part, scanning and the uploading.
So how many questions can we expect?
How does it matter? I mean, I can always, I can define it as one question with several parts. I can define it as several different questions. Whatever I tell you is not going to be very helpful. You know, don't worry about that. I mean, there's should have plenty of time to answer the questions.
Excuse me, sir.
Yeah.
Is it going to be of 15 marks, or is it going to be more and then scaled out?
Ultimately, once again, how does it matter? I can mark you out of 100 and then scale it down to 15. Eventually, it'll carry 15 marks for the course as a whole.
Yeah. No problem.
Okay. Any material, any concepts that you want me to discuss? Any doubts?
Sir, this is not related to the course, but related to the exam, sir. Will you be sending the instructions beforehand for like any particular instructions for the exam, or like you'll send it that time only? Like what to mention on the first sheet and everything?
So I just posted last year's exam. You know, that has the instruction sheet for online exam taking. So it'll basically be the same. So look at last year's exam in the first sheet there, and that will have the instructions and will give you a good idea as to what to expect.
Okay, sir. Thank you.
So,
Yes.
so in one of the past years, like in 2-3, I saw that we are given the production functions for 2 factories, and then in one of the parts it says that that the 2 factories merge to become a monopolist, and we need to find their cost. So, sir, I'm not able to get that. Like, how do we calculate or how do we approach it?
Okay, so let's look at it.
So
Yes.
related to that same question that Vidushi mentioned, so in the first part, we're supposed to derive the cost and supply function of each firm. But like we're given 2 firms, but do we have to assume that they're perfect competitors, since it's not mentioned before that part, basically?
Usually it will be mentioned. If it's not, if it doesn't say monopoly or anything, by default you can assume perfect competition, but usually it's mentioned.
Okay, so
okay.
Sir,
Yes.
so in this particular question is assuming it to be a perfect competition. Is that a good enough assumption? Because if we consider 2 firms that merge to become a monopoly, then it must have been a duopoly before that, right? So is that a good assumption to use it as?
It's a stylized assumption for the, I mean, the essence of the assumption of perfect competition is price taking behavior. Now I can specify a problem where I say, oh, there are only 2 firms, but for whatever reason they act in a price taking manner, right? It's logically consistent. I mean, it sounds weird that with 2 firms, why are they not behaving as oligopolists? But we are not building a realistic model here. We are just exploring the implications of the perfect competition assumption. So for the purpose of a problem which you can solve in quick time, I've given you just the simple two-form scenario, right? Of course, if you're serious about an industry which has only two forms, and if you assume when you're doing analysis of a real-world situation, you shouldn't assume that with two forms they act in a price-taking manner. But this is a theoretical question on paper. So forget about those qualms and just get down to the assumption of perfect competition as the question asks you to assume. Yeah.
Yes, sir, it's clear now.
Okay. All right. So this is last year's midterm. So here you have the kind of question that was mentioned. You have two production functions, two different factories. Okay. So the question could be that, find the cost function of each firm when they're separate entities. And if they merge, what is the combined cost function? Okay, so let me so here are the two production functions, min L1 for K1. Okay, so let me write that out first. L1 for K1. Square root, and Q2 is 2 L1 to the power 1/4 K1 to the power 1/4.
So it should be L2 and K2.
Say that again.
It should be L2 and K2 in where it's
Right. Yeah. Capital is 4 per unit, labor is 1 per unit. Okay, so let's first construct the separate cost functions when they're separate entities. Yeah. So let's pick the first one. Of course, we know that this is a version of the Leontief. It will have L-shaped isoquants. So the optimal will always involve choosing the kink, which is this. Okay. And so that means L1 will be Q1 squared, right? And K1 will be, so Q1 is root over 4 K1. So you square that and you get 1/4 Q1 squared. Okay, so what is the first cost function?
4 Q1 square plus 1/4 Q1.
Right, 1 times, so in general it's WL1, W is the price of labor, times R K1, R is the price of capital, W is 1 over here, and L1 is Q1 squared. So we have Q1 squared plus R4 times this. So the 4 cancels out. So you have another Q1 squared. So you have 2 Q1 squared. Okay. So that's our first cost function. Second cost function. This is Cobb-Douglas. Now I'm going to take a little bit of a shortcut here. Essentially, the first order condition for cost minimization, as you know, is MRTS, marginal rate of technical substitution, which is the slope of the isoquant, should equal the price ratio of the inputs. So MRTS here will be K2 by L2. You should do it more fully. I'm just quickly trying to get to the answer. Is equal to W by R, which is 1/4. Okay, so L2 is 4 times K2. And if we now throw it into the production function, Q2 equals two times L2 to the power 1/4, which is this to the power. So we'll have a K2 to the power half. Okay. And 2 times square root of 2, isn't that? So if we square both sides, we get K2 equals
2 squared by 8.
1/8 times Q2 squared. And L2 therefore will be 4 times this, which is half Q2 squared. So our cost function is equal to W times L2. So that's this half Q2 squared. And then
It's coming out to be Q2 square only.
Q2 squared. Okay, that's the second cost function. Okay, now let me now get to the question that was asked, which is that suppose these two forms merge, or one of them buys up the other. So now we have what is called a multi-plant monopolist, a monopolist who can allocate his production across these two production facilities. Okay. So what we want to do, what approach to the monopolist problem, is to construct a combined cost function CQ. Okay, what is the exercise which gives rise to the combined cost function? It is minimize total cost, combined cost of the two factories, subject to some given production target, Q1 Q plus Q2 equal to Q. Right?
Yes, sir.
And we can convert this constraint optimization problem into unconstrained problem in the following manner: minimize C1 as a function of Q1 plus C2, just replace the constraint Q minus Q1. Okay, here the choices were Q1, Q2, both the quantities. Here the choice basically becomes Q1. The residual amount is produced in the other factory. So if there's an interior solution, what is the first order condition? First order condition is C2 prime. So the monopolist will always allocate a total production target across the two factories, or n factories if there are more than two, so that the marginal costs are equated. That's the principle, right? And the intuition should be very obvious. If the marginal costs are not equal, then you can always reallocate some production from the higher marginal cost factory to the lower marginal cost factory. And in the process, your total cost is going to come down. So if you apply this equating marginal costs in this example, C1 was 2, so marginal cost is 4 Q1. And in factory 2, marginal cost is 2 Q2, which is 2 times Q minus Q1. So from this, we can solve for the optimum Q1, which becomes minus 2. Optimum Q1 is, there's a 2Q
1 by 3Q.
minus 1/3 of Q. And therefore Q2 is 2/3 of Q, right? And now you plug it back. So the cost function for the monopolist, consolidated cost function, is C1 of Q1, right? So 2 times 1/3 Q squared plus this 2/3 Q squared. So you have 2 by 9 here, and you have 4 by 9. So 2 by 9 plus 4 by 9 is 6 by 9. So 2/3 Q squared. So that's the cost function for the multi-plant monopolist. Yes?
Sir, is there a way for us to know what production function will the merge firm follow out of these two?
Why do you need that? It's
No, sir, just a general question. I know how to solve this. I'm just asking whether we'll be able to know that what production will the merge firm follow out of the two that we are taking.
no, I think the answer to that is no. Because how the output is allocated across the two individual production functions, that depends on factor prices. If you change the factor price for the same output level, the firm will switch around allocation of production.
So, sir, in a merge firm as well, there are different production functions at different places.
That's right. There's no,
okay, sir.
yes.
Okay, sir.
So the answer to your question would be, what you're seeking is some aggregate production function for the merged firm.
Yes, sir. Yes, sir.
Independent of factor prices, right? If the production function includes factor prices, then that's not really a production function. But as we know, as we see in solving this exercise, that the firm, how it allocates its output across the two plants depends on what the prices of the inputs are.
Yes, sir.
So you cannot construct, you can construct a consolidated cost function, but not a production function. Okay, questions? Okay, let's focus on part C of the problem. So let me read it out. So in part B, you have to solve it as a perfect competition problem. Each firm is a price taker. You have found their cost functions, as we did, right? The individual cost functions. And from each individual cost function, you can find the supply function of each firm, right? So just very quickly, what will, when both of them are competitive, what is the supply function of firm one? Price equals marginal cost. That's how competitive firms behave. So P equal to MC1 gives us, what is MC1? 4 times Q1, isn't it? So this means Q1 equals P by 4. So this is the supply function of firm 1. Similarly, for firm 2, they'll set market price equal to their own marginal cost, which is MC2, which is simply 2Q2. So Q2 equals P by 2. All right. So for the part of the question which says both are acting in a perfectly competitive manner, you add up these supply functions, then look at intersection of demand supply, that gives you market equilibrium. But let me come to part C of the question. So part C says, suppose firm 1 acts as a dominant firm who sets the market price P. Firm 2 takes the prices given and chooses its supply, while firm 1 meets the residual demand. Find firm 1's profit maximizing price and the resultant market allocation. So for any price P that, that firm 1 sets, firm 2 supply is given by this equation, Q2 equal to P by 2. Okay, so what is the residual demand?
The entire demand subtracted from the supply that the firm 2 gives.
Right. So what was the demand function? Demand function was given to be P equal to 1 minus Q. Okay, so the direct demand curve is Q equals 1 minus P. From that, you have to subtract the supply coming from firm 2, which is P by 2, right? So this is the residual demand for firm 1. Okay. So what is firm 1's problem then? This is how much firm 1 can sell. So what is firm 1's problem? It is max. Okay, let's actually invert this. So this is 1 minus 3 by 2P. So if we switch sides, we get P equals 2/3 1 minus Q. Let's just call it Q. Okay. So firm 1 solves maximize profits. So profits is revenue part is 2/3 1 minus Q. That's the price they can command times Q. And the cost function is firm 2. So the cost function is just Q squared. So this is what the firm will say.
Sir, I think I might be a little confused here, but the question says that the dominant firm chooses the price.
Yes, so that
So
is.
shouldn't we write Q in terms of P
Okay.
instead of writing P in terms of Q?
So let's review it. What was the first step? The first step was I derived the residual demand for this dominant firm, right? And that's given by this.
Yeah.
They set a price P, they're able to sell this much. Okay.
Sir, yeah, sir, I'm just talking about the last part where you've written maximize the profit, where the variable is Q.
I understand.
Shouldn't the variable
I understand.
here be P?
I'm explaining that, right? I want to formulate the problem as a choice of Q because my cost function is in terms of quantity, right? So that's the convenience I have. Now I'm taking the question at face value. Okay, so let's start at the beginning. Let's start here. The dominant firm sets a price P. Okay, for every P that it sets, the quantity that it will be able to sell is this much. Okay, now setting a price P because there's a one-to-one correspondence between every price P it sets and the quantity that it can sell, the firm might as well think of a choice of quantity, right?
Yeah.
It's just whatever optimal quantity we have solved here, they can go back to this equation, see the corresponding price, and then set that price, right? Because through the residual demand function, price and quantity have a one-to-one relationship. You can formulate the problem either as choosing a price or as choosing a quantity. The firm really has one degree of freedom. Yeah. So this is exactly how a standard monopoly problem is analyzed, right? Forget about the residual demand curve. Suppose this was a monopolist and this was the original market demand function, right? Then this is exactly how we'll solve the problem.
Yes.
Yeah. So that's
how's the cost is Q square?
Because we derive the cost function.
So it will be 2Q square.
Oh, I see. Okay.
Sir, it will be Q square. So Q1 square actually. If you've written it as, if Q here means Q1, then yes.
Yes, it means Q1. So it is going to be 2Q squared, I think. Yeah, because the dominant form is form 1.
Yeah.
And form 1's cost function is 2Q. Yeah. All right. Okay. Let me look at part 1 of question 1 from last year. Okay. So I don't know if you have looked at this already, but I just posted it in the last minute. But let me recap what the question says. There's a household who has this Cobb-Douglas utility function. They consume 2 things, food and movies. The government wants to give some aid to this household, right? And the government has a budget of 25 rupees to give to the household. The household's own income is, I think, 100 rupees, yes. So this 25 rupees of extra resources are going to be pumped in to help this household achieve a better standard of living in some sense. Now, the government is paternalistic. The government has its own view about what constitutes welfare for this household. And this is captured by saying that the government utility function projected onto the household is the min function, the Leontief function. So if the government could control the choices of the household, okay, then they would use this utility function to make choices for them. However, the government cannot make the household choices, right? The government can only choose what form of aid to give, but consumer sovereignty applies to the household as far as its own money is concerned, the 100 rupees that it has. So the question asks you to calculate, to look at 3 scenarios. One is the government gives a cash grant of these 25 rupees, full flexibility. Another is in-kind grant of 5 kgs of food. Okay. And third is a food subsidy of rupees S per kg. And here the catch is, so the very first part of the question says, what has to be the value of S so that the total subsidy bill is exactly 25 rupees, right? The amount of money which the government has to give out. So in the case of a subsidy, the subsidy rate has to be chosen so that the budget is not exceeded for the government. Okay, let's first focus on that. So how do we solve that problem? Well, you take an arbitrary subsidy rate S first to begin with, okay? And then calculate the demand functions of the household as a function of that S, okay? So what are the prices? Price of food is 5 and the price of movies is 1. So the private cost in the subsidy regime, the private cost of food to the household is 5, the market price, minus S, whatever the subsidy is, price of food. And price of movies is 1 as usual, that's not being subsidized, okay? They have Cobb-Douglas utility. So I'll exploit what we know. Again, you should derive things when you're answering a question like this, but I will, we know what, so the amount of the demand for food will be one-fourth the exponent on food, right? 1/4 of the income will be spent on food. So 1/4 times income, which is 100, divided by P minus S, which is 5 minus S, okay, which is 25 divided by 5 minus S. So this is how much food they will buy. And so the total subsidy bill is subsidy per unit times the amount of food they consume. So that's 25S divided by 5 minus S. And that has to match 25, right? The total amount available. So that cancels out and we end up getting 5 minus S equal to S. So S is 5/2. Okay, so that's how you calculate the subsidy, which is affordable to the government. Yes, it utilizes the voluntary choices of the household.
Sir,
Yes.
so while choosing which of the ways is the best, will we use the consumer's utility function or the utility function that government
I'm come
thinks?
to that. So
Okay, sir.
Sir, I have a doubt in this part. So you are calculating the total subsidy of 25 using the utility function of a consumer, but it's the government who measures it using its own utility function, min function. So, sir, shouldn't that be given instead of using
I'm explaining it. Hold on till I get to the end of it, and then let's ask me what your doubts are, right? Just focus on this component. I mean, over here, in either of your questions, there should be no doubt, right? What is the subsidy rate the government can afford? Yes. The question says that the household will choose what is in its own interest. The government cannot force the choices of the household directly. The government cannot say that, okay, this is how much food you have to buy, this is how much movies you have to buy. The government can try to influence their choices by through its form of aid, but it cannot directly do so. So once you fix the form of aid which the government is giving out, whether it's a cash grant, whether it's an in-kind grant, whether it's a subsidy, right? Once you fix that, after that, the household will choose whatever is in its own interest, and therefore the relevant utility function will be the household's own utility function at that point.
So I had one question with regards to this. So what exactly does paternalistic mean? Does it mean that the government is unaware of the utility of the household, or is it that it just evaluates it differently, like a father? Like
it evaluates it differently. Like we have talked quite a lot about welfarism versus paternalism, right? Welfarism is the view where somebody like the government says, oh, I'll judge the welfare of this household by their own utility function. Whenever they think they're better off, I'll respect that and I'll say they're better off. That's welfarism. Paternalism is where the government or whichever party it is disagrees with the household's own utility function.
It's like, I know what's better for you better than you know.
That's right. Exactly like parents, that they don't want to give money to the kid because the kid will go and buy junk food or chocolate. So the parent buys some books with the birthday money, right? That's because in the parent's view, books should play a more prominent role in the utility function of the child, but the actual utility function of the child puts much more weight on chocolate and junk food. Yeah, so it's exactly like that. And so what this question does is that it takes a problem involving of aid giving, building in this sort of paternalistic considerations, and then goes on to ask, what's the best form of aid, given that there's a paternalistic motive. Yeah, so it is, yeah, exactly. Paternalism comes from the fact that it's like, in some sense, treating the recipient like children.
Got it, sir.
We are not necessarily saying it's a good thing or a bad thing. We're taking it as given and analyzing it. Okay. Now, so, right. So let's discuss conceptually how to go about solving this problem. So you take each form of aid. Okay. First, you take a cash grant. Taking that as given, cash grant means what changes for the household? Their income gets bumped from 100 to 125. The price of food and movies remains at 5 and 1. They just have an income boost to 125. You can solve the household's demands, optimal allocations in that scenario. Okay. So find the value of F and the M under the cash grant. Once you have, okay, so you solve for that, all right. Scenario 2 is this in-kind grant of 5 kgs. So once again, you take that situation as given, you solve for the household's choice of F and M. And finally, for the subsidy, where you have found that the subsidy which the government can afford is 2.5 per kg of food. So you take that numerical value and you calculate things. Okay, so for each of these scenarios, 1, 2, and 3, which are different forms of giving the 25 rupees available for aid, you can solve for the values of F and M that the household will choose based on the household's own utility function, which is this. Okay, so you have these three, all this information in hand. So now the final question is, which form of aid will the government prefer? Okay. So the government's utility function, as you can see, is this min form. So essentially, it'll be focused on food. So essentially, it'll boil down to, notice that the household puts much more weight on movies, right? So the tension always will be for the government trying to make them consume more food in this question. So once you have solved for the values of food consumption and movies consumption for the 3 cases, the government will obviously choose that regime where the food consumption is the highest. Okay, so that's what you have to find as the final step. So in the 3 cases that you have solved for, the numerical values, where is the value of F the highest? And you will find that it's for the subsidy regime, actually. Okay. So there are two sets of questions here. Which form of aid does the government prefer, and which form of aid does the household prefer? Okay. So to answer which form of aid the household prefers, again, for each aid regime, you have found the values of F and M, so you can plug that back in and calculate the utility of the household. So the household will choose the one which gives the highest utility, or prefer the one which is the highest utility, and the government will prefer the one which gives the highest value of food consumption. Okay, so once you've found the numerical values, you can calculate each of these things. Now, that's putting it mechanically. Let's take a step back and review. Can we guess the answer without even doing the calculations? So for the household, what is the best form of aid?
Cash grant, sir.
So the cash grant.
Yeah, because it gives them maximum flexibility. Okay, whatever they could afford in under any of these other regimes, they could afford with the cash grant, right? And usually they have more choices available to them. So cash grant will be the highest, followed by?
So the 5 kg grant.
Followed by the 5 kg grant. Okay, so I think so for the cash grant, so what is the food consumption? Yes, so the 5 kg grant, if you calculate it, it will turn out to be inframarginal. Okay, so if they have 125 rupees, they'll spend 1/4 of that on food, and that at 5 kgs, 5 rupees per kg, that means more than 5 kgs of food. So the in-kind grant will not make a difference. Remember, we had a whole discussion about this in class. It's an inframarginal in-kind transfer, which means it's as good as a cash grant. Yes. And the subsidy will be the least preferred of the household, whereas you will find that for the government, it's the subsidy which is the most preferred because it leads to the maximum food consumption. Because what the subsidy does is that it nudges the household towards more food by making its private cost to them cheaper than the market price. Okay, so let me not do the calculations. I hope it's clear how to proceed to solve this problem. And don't get confused when it comes to how much will the household actually consume of food, movies. It will be based on their own utility function and maximizing that utility function. When it comes to what form of aid will be chosen, there the government will use its utility function, right? This paternalistic utility function, but using the choices that the household itself will make, right? It's not like the government can now choose, make the choices for the household based on this utility function. No, right? The values of F and M, based on which the government will evaluate its utility function, those values will be coming from the household's own voluntary choices.
So when we say that the government will choose the grant that gives the highest food consumption, it is because of this particular utility function, right?
That's right. That's right. The more general.
In other, yeah, so we'll always maximize the utility only for the government as well.
Right.
Okay, sir.
So the general approach is that you solve for the household's choice of F&M under each aid regime and plug in those values to calculate utility as far as the government is concerned. From its
okay, sir.
Yeah.
Excuse me, sir.
Yes.
Sir, in the problem set, there was a question, which form of grant is more efficient, more economically efficient? So, sir, was it, it was written, you have to analyze, was it distortionary subsidy or lump sum cash transfer?
Mm-hmm.
So, sir, in that, I was getting utility numbers different. Matlab, in subsidy, U bar was coming out to be 3.99, and in lump sum U bar was coming out to be 4.21, and V bar in subsidy was coming out to be 3.67, and V bar is coming out to be 3.5. So, sir, what should we do? So, we should evaluate the utility, total utility, by taking the government perspective or by taking the perspective of the consumers.
Well, there are two different perspectives. I mean, I'm not sure what exactly the question is. The question is which form of aid is more efficient.
The question is, it's normative actually. The question is subjective. So the choice essentially boils down to which utility should we maximize. So is it the welfarism or the paternalism? Right. So there is no one unequivocal answer for this.
Right. So in a
Sir,
situation,
in one part, U bar is greater, and V bar is greater in other part. Like in
right, so that's why there's a tension between
yes, sir.
the government's interest versus the household's interest, right?
So, sir, how should we go answering this? What should we say? Matlab, what should we answer in this?
You have to tell me the exact question. What's the exact question?
Sir, it was critically analyzed which form of grant is economically efficient. Was
Yeah,
it?
so the answer to that is that, I mean, not every question has a simple answer like 42. So the answer to that is here there's a clash between the interests of the government. The interests of the government means its own paternalistic view of what is good for the household, and the household's own view of what is good for itself. And there's a trade-off, there's a tension over there, right? So as third parties, as onlookers, what do we prefer? I don't know. And then we have to decide.
Sir, can we write like this, like considering cases like if we say we are evaluating utility with the perspective of consumers, we can say lump sum cash grant is better, and if we are evaluating utility with the perspective of government, then subsidy is better.
Yes, so that is the general lesson, right? That is the sort of upshot of these exercises, which is that from the household's perspective, cash grant is always better, right? That's also economically efficient in the sense of deadweight losses, etc. But governments often move away from cash grants into distortionary instruments like subsidies, because the government has paternalistic views. The government wants to override or manipulate the household's choices because it has a very different view of what is good for the household. So that's our understanding. Now, we don't have to take sides, right? It's an analytical insight that we get.
Sir, but we have learned that when there are policies that distort choices, there is a deadweight loss. So here in this case, we know that evaluating from the government's perspective, we get food subsidy to be the most efficient, or the one that's giving us highest utility. But we also know that this is giving us a deadweight loss, so it's not economically efficient. So could we also bring in this argument that the grant or the aid that does not distort choices is the economically efficient?
Yes, that's a good point. Let me say this. There's a deadweight loss. If you kind of unpack that in this context, what that means is, take this problem, right? If the government is giving the aid, the government will give it in the form of subsidy, and that will be distortionary and have a deadweight loss, right? What that means is the government and the household could, in principle, enter into an agreement where the government hands over the 25 rupees in cash and the household commits to a certain minimum food consumption. Suppose they sign a contract, right? If signing such binding contracts were possible, then compared to the subsidy situation, there would have been a contract which would make both the household feel better and the government feel better. That's what it means to say that the subsidy is distortionary and creates deadweight losses. Okay. Now, in reality, such contracts are highly unrealistic. Okay, if you just think about it, that can the government go and give cash transfers to household and say, oh, you have to? Well, sometimes they do actually. There are what are called conditional cash transfers, right? There are examples from Latin America, for example, where the cash transfer is given conditional on, for example, the household sending its children to school. Right? If they pull out their children from school, they lose the cash transfers. So those are examples of trying to get the efficiency and flexibility of cash transfers in place, while guaranteeing that certain virtuous goods and services are consumed to the required degree. So yeah. So the inefficiency means that there is room for such Pareto improving deals where the household by its own utility function and the government by its utility function could both reach a better situation. So the only question is the practical feasibility of such improvements.
So I have a point to add here. So just like she actually pointed out, there will be a deadweight loss. But the thing is, my question is deadweight loss a bad thing? Because like in case of taxation, that creates deadweight loss, but that's not actually a bad thing, because if you see if you try to see the larger picture, that creates other like better things. So if we consider to be a single problem, yes, it creates deadweight loss. But if we try to see the like larger picture, this deadweight loss doesn't actually matter. So I don't know. So that was my point.
Yeah. So deadweight loss, is it a bad thing? It's not like an unmitigated evil. You know, the lesson here is not that we should try to avoid deadweight loss no matter what. Right? Deadweight loss is a bad thing in the sense that in principle, there exists a better options, which is better for everyone, right? Which is a Pareto improving option. Now, if that Pareto improving option is not, cannot be realized, right? For various kinds of real world constraints, implementability, et cetera, then there is no overarching implication that we should avoid deadweight losses at all costs, right? So here for the government, if putting some conditions on the household is ruled out for questions of feasibility, then the government may want to stick to the subsidy, right? And we as economists and analysts, citizens, whatever, you know, it won't be an unreasonable position for us to take that say we support the government in this, you know. And nutrition is a problem. We agree with the government's utility function. There's deadweight loss, but at least, you know, this will improve national nutrition. So yeah, I agree with you that, you know, we have to, deadweight loss is just pointing out that in principle, you know, we should try to avoid the deadweight loss. Now, if there's no realistic instrument which will make us avoid it, then we have to make a hard choice, right? And then the best choice could involve deadweight losses. So what?
Sir, adding to Shonak's question, like it is a point of debate that it is deadweight loss is good or bad, but why do you have a negative connotation attached with it? Like it is deadweight, why it is called so?
Don't attach a negative connotation, right? The people have criticized economics. One foremost critic is Ariel Rubinstein. And Rubinstein has a paper with Michele Piccione called Rhetoric and Economics. And one of the points, especially Rubinstein is making, is that many of the terms in economics have very concrete meanings, but the words we use have connotations which go beyond the specific meaning. Take the term efficiency or Pareto efficiency. Pareto efficiency is actually a very weak concept. To say that an allocation or an outcome is Pareto efficient is saying very little. It's damning it with faint praise, right? A situation where a few billionaires control all the wealth and income and many people are almost starving or living on the streets. It could be a Pareto efficient situation. So the term efficiency, you know, if you can manage to keep the connotation away from your head, right? When we say, oh, this allocation is Pareto efficient, we mean something mild and tightly circumscribed. But the term efficiency kind of triggers positive feelings in our heads. And if people haven't understood the concept very well, or if they've understood but they're kind of forgotten, then they may reach a kind of a comfortable mental space where they think, oh, things are efficient, let's leave it to markets. Let's never intervene. So yes, I mean, many of the terms in economics have this problem of connotations. Right? They connote sort of larger, bigger sentiments than what is actually warranted when you look at the exact meaning of those words. So as advanced students of economics, you just have to be aware of that problem. And whenever you see somebody with just a basic course in economics, holding forth and spouting about, oh, markets are efficient. Why does the government have to regulate it and bring in this and that and subsidize this, subsidize that? You point out the subtleties and the nuances that you have learned. Right?
Excuse me, sir.
Yeah.
At the risk of repetitions, I just wanted to clarify one thing. At no point do we use the government's utility function for finding optimal choices, right? We just use
That's
it
right.
to plug in
Yes.
what we have found from the consumer's utility function.
Absolutely. Very well put.
Right. Right. Thank you, sir.
Excuse me, sir.
Yeah.
As our question, it was in the past year's end term. It was basically a monopolist who's also buying his inputs from another monopolist. So how exactly would that framework work? I'm just unable to sort of conceptualize it. Like, how is the second monopolist, able to construct a demand function or anything in that case?
This is the very last.
Yeah, exactly. So
yeah.
Yeah.
Can you tell me which year's question it was?
2020. I have it's from 2020's final exam. Summer semester 21 to 22. It's written on top. So it's 2020s. No, sir, I don't think it's this paper.
Anyway, let me.
So if you want, I can just read it out, like the basic stuff. That's pretty small.
No, I'll tell you. Let me refer to the slides here. So it refers to this problem. Okay. It's pretty much this problem which I discussed, which is on the slides. It's putting some numerical values, I think. Okay. So here you have this. You need 1 unit of wood to make 1 unit of furniture, and there's an upstream monopolist. There's a downstream monopolist. There's a demand function. Px is the inverse demand curve. So how do we solve the problem? Well, we solve the problem backwards. Okay, so the upstream firm, the firm which is the logging company producing the wood, let's say they have announced a price of wood, which is Q, right? Q is here not quantity, it's price. Okay, now the downstream firm, the furniture monopolist, will take that Q as a given, okay, and it will solve its profit maximization in the standard way. So revenues minus its own cost. Cost includes its CX, its marginal cost of everything excluding raw materials, and the price at which it has to purchase wood from the upstream firm. So that's a very well-defined problem. So that's the first problem you write down and solve. Okay. The downstream firm, which is selling directly to the product market. So their problem, from that you get their demand for wood. Okay, if I gave you the functional form of this, for example, it's a linear demand function. So you have 1 minus x, p equal to 1 minus x, let's say. So based on that, you can calculate the exact demand function for wood as a function of Q coming from the last monopolist. And then you go back a step and you go to the upstream firm's problem. The upstream firm takes this derived demand function coming from the next monopolist and solves its own profit maximization problem. Okay. And That's how you solve it. So the question there, I think, is basically, you just follow these two slides using the functional forms I have given you in the question, and that's it.
Okay, yeah, sure. So I'll go through them once. So thank you.
So there's a similar question to what we were doing about the production theory, where there's a single monopoly form which could combine production across two different factories. But sir, the problem here is that the production function in one of the factories is just minimum of L comma K. So the cost function that we get, the marginal cost function, is linear. And then for one of the factories, we get supply function, which goes like 0 if P is less than, let's say, 3, 0 to infinity if P is equals to 3, and infinity if P is greater than 3. So when we are combining the two factories, the output that we'll get, it will also be in interval terms, right? And then the three conditions.
Yes. So this is a case I think you're referring to, which will involve some corner solutions. So let me skip a derivation of the cost functions. So suppose we have a problem like this. One cost function is usual strictly convex. Let's say Q1 squared.
Mm-hmm.
Okay. And the other cost function is
3Q1.
Yeah. So it's some alpha times Q1. Okay. So marginal cost here is increasing, 2 of Q1, and marginal cost here is constant, just alpha. Okay. Now here, what will be the allocation of production and what will be the combined cost function? Okay. Now think about it intuitively first. Let's draw the two marginal costs here in this picture. So 2 of Q1, that's like this straight line, and the other marginal cost. So this is MC1, and this is MC2. Okay. So suppose the total output of the firm is small. In particular, let's say it's Q star is where the two marginal costs intersect. What if the firm is trying to produce something Q less than Q star? Okay. Can you tell me what the optimal allocation there will be?
So shut down the factory too?
Yes, because even if everything is produced in factory 1, as you can see, right, the marginal cost is still less than the constant marginal cost in the second factory. So there's no production we will allocate to the second factory. Okay, so as long as Q is less than or equal to Q star, this cutoff, the optimal allocation is everything is produced in factory 1 and nothing Q1 equal to Q and Q2 equal to 0. Okay. Now, what of quantities which are greater than Q star? What will be the optimal allocation there?
So shut down factory 1.
No.
It will be a combination of both.
Yeah. So every time, anytime there is an interior allocation, right? The principle is MC1 equal to MC2. Okay. Right. Now, if the total production Q is over here, then how can you, what will make sure that MC1 equal to MC2?
So is it possible
till Q star be produced in factory 1 and after Q star be produced in factory 2?
Yeah. So factory 1 will involve this Q star amount, and the remaining production will be allocated to factory 2. So Q minus Q star goes to factory 2. Okay. So up to Q star produce everything in factory 1. And as production target exceeds Q1, all the extra amount is produced in factory 2 because its marginal cost doesn't climb with extra output. So that's the optimal allocation rule in this case. Right? So if you want to be just so what is the Q function in this case? The Q function will be, you'll have to write it in this manner: Q less than equal to Q star. There, all the output goes to factory 1, and factory 1 has this cost function. So the combined cost function will be Q squared up in this range. And for Q greater than Q star, what will it be? It'll be Q star is produced in the first factory, and the remaining is produced in the other factory, so Q minus Q star. So that's your cost function. Okay, you have to write it in a piecewise fashion. Yes, does that answer your question?
Yes, sir. So there's another case within this question where we are finding equilibrium price and quantity in the market when there's perfect competition.
Right.
If you could just quickly go over that case as well.
Okay, so what is the supply curve if it's perfect competition? What will be the supply curve? Anyone?
So it will have 0 if price is less than alpha. It will be 0 if price is equal to alpha, and it will be infinity if price is greater than alpha.
Yeah, basically consider all price. So this is alpha. So if the price is here, right, then the price is below the marginal cost of the second firm. Right now, the factories are owned by different firms, price-taking firms. So firm 2 doesn't produce anything at all. And how much does firm 1 produce? That's from firm 1's marginal cost. Yes. So for any price below alpha, essentially all the supply will come from firm 1, and firm 1's marginal cost acts as the supply curve. Now, the moment the price hits alpha, firm 2 is willing to supply an infinite amount, right, at that price, or anything up to, from this point onwards. And at any higher price, of course, firm 2 wants to just go all the way to infinity, so those prices will never arise. So essentially, the supply curve of the market, consisting of these two firms, will be this green part, right? It will be this part of the firm 1's marginal cost curve, and once you hit this point, it becomes flat because firm 2 jumps in and will produce anything, any amount that is needed. Right?
So, sir, for P greater than alpha,
yeah,
the first firm won't produce anything because the entire demand will be catered to by the second firm. Is that what we're
well,
saying?
it can produce, if the first firm will be interested in producing a finite amount right off from its own marginal cost curve, but that plus infinity is still infinity, right? So the market supply at any price greater than alpha will be infinity.
Okay.
Some finite amount from firm 1 and an infinite amount from firm 2. Okay. Whenever you have these constant marginal costs, prices above that become irrelevant. You will never have a market equilibrium at a price higher than that, because then
so we are also given a market demand function.
Yes.
Which is equal to P is equals to 4 minus 2Q.
Right.
And the alpha here is equal to 3.
Yes. Yes.
So would we?
So now it's pretty simple. Once you have this market supply curve, right, and you can write down its mathematical form easily. I'm not going to go through all the details. Now you bring in the demand curve, right, and you have one of two possibilities. One is that the demand curve passes like this, It intersects the supply curve in this rising section. In that case, in equilibrium, firm 2 won't supply anything. The price will be below alpha, and all the supply will be from firm 1. The other possibility is where the demand curve is like this. So there it intersects the supply curve in its flat segment, and that's a situation where both firms will be supplying some amounts.
So, sir, how do we figure out what that sum amount is?
Well,
how do we figure out the division?
Okay, so here's one thing you can do. If you want to calculate the exact numerical values, right? Conceptually, diagrammatically, this is what the market equilibrium will look like. Now, are we in this case or are we in that case? Well, do the following. You say the market demand curve is P equal to 1 minus Q, let's say, or inverse demand function. Now, for a moment, assume that equilibrium market price will be alpha, right? That the flat segment will be relevant. Okay. If that is the case, then what is the equilibrium quantity? It's 1 minus alpha. Okay. Now, is that the true equilibrium? Well, if the picture looked like this, then this will be 1 minus alpha, right? And that is to the left of the kink, right? So in this case, the actual equilibrium will not be on the vertical horizontal segment. It'll be in this rising segment. Okay. So once you do this, you find this candidate quantity 1 minus alpha. If 1 minus alpha is higher than this Q star, greater than equal to, then this is the true solution. Yes. If 1 minus alpha happens to be less than this Q star, then throw out this solution. Then this is not the true solution. Then we are, this blue part. Okay. And then how do we find the actual market equilibrium? You just ignore firm 2. You just look at the intersection of the demand function with firm 1's marginal cost, and that intersection gives you the equilibrium price and quantity. So when you have a kink like this, once again, to recap, you first assume that the equilibrium is in the flat segment, find the quantity, and see if the quantity lies to the right of the kink. If it's to the right of the kink, you have found the true market equilibrium. If it happens to the left of the kink, then this is not the true thing. Then you throw away the firm which has this constant marginal cost, ignore it as if it doesn't exist, and you find intersection of demand and marginal cost of firm 1. That's the way to go about it. Now, I'm not looking at the exact problem where you have numerical values there. I could exactly solve it, but this is the method. This is the approach.
Sir, I had a doubt.
Yeah.
Sir, in one of the past years, there was the same question regarding the paternalistic government, where we needed to derive the optimal ceilings that the government would put on consumers' consumption. So, sir, even in that case, we'll first find out the optimum values of the consumers, optimum values, and then substitute them in the functions of government, utility function of government, to find out the optimal ceilings.
Yeah. So, you find what the household's optimal choice is if they are left to themselves, let's say, without any kind of restrictions, this is what they'll consume. Then you find out what the government, if the government could make the choices for the households using that paternalistic welfare function, what would be the optimum food and movie amount for the government? So let's say that's FG, and mg. Okay, so if, for example, fg is greater than fh, which means mg is less than mh. Okay? So the government wants the household with the same resources, same income, to consume more food and watch fewer movies. Suppose this is the case. So then if the government can put a ceiling on the consumption of some good and implement that ceiling, what the government would like to do is put a ceiling on the consumption of movies, right? So what would be the ceiling? The ceiling would be set it equal to what exactly the government wants to the household to consume. So once they cannot go beyond that, they have to spend the rest of their money on food, and food consumption will match what the government wants.
Okay, sir.
Yeah. So the ceiling question is very, very easy. But ceiling is a very blunt instrument, right? In reality, that's basically saying you can have this intrusive monitoring of the household, how much they're buying. You can audit and check that, which is often unrealistic. Yes.
So
yeah.
In the same question, if you need to calculate the subsidy that a government would like to give, so we'll be using the utility demand functions of consumer.
Yeah. Well, in calculating what the household will choose, yes, you'll use their utility function. But in evaluating whether the subsidy is a good form of aid, there you will use the government's function, using the household's own choices.
Okay, sir.
Sir, in the question that you discussed before this, can you just scroll up a little?
Yeah.
So here I'm not clear how we'll find Q star. I mean, so I took that case where P is equal to alpha and I found the total quantity. And so I'm not able to understand what we'll do after that step.
Okay, so how do you exactly calculate Q star? This way. What is Q star? Q star is the quantity at which the two firms' marginal cost curves intersect. Okay, so take MC1. What is MC1? 2Q1. 2Q1. Okay, and that has to match alpha, right? So for what value of Q1 is this true? Well, for Q1 equal to alpha by 2, and this is exactly Q star. Right, it's that quantity. If you gave it entirely to one, their marginal cost will be exactly alpha, the other firm's marginal cost. I mean, just look at the diagram, right? We are trying to find this point of intersection. What is this point of intersection? It's the intersection of the two marginal cost curves. What does that mean? That means, one marginal cost is constant at alpha. So at what quantity does the other marginal cost assume the value alpha? Well, you know the equation of this MC1. It's 2 of Q, right? So at alpha by 2, we have this intersection. So Q star is equal to alpha by 2.
Got it, sir. Thank you.
Sir, I had a last doubt. Sir, suppose that there is an in-kind grant that the government wants to give, and first we calculate the amount of food that the consumer wants to consume. Sir, suppose that's less than what the government is giving as an in-kind grant. So, sir, he'll be using to consume food using the in-kind grant and spend all the money on the movies.
Yes, and the question that is in the problem set, the optimal food choice for a consumer without any aid comes out to be 3. And the in-kind grant is more than that. So the consumer would spend all his income only on movies, right? So can we take this logic to work?
Because this was using the diagram that you had told that we'll be consuming at the kink point.
Right. So let me, yes, I mean, in today's discussion, I claim that it's inframarginal, meaning the in-kind grant of 5 kg is less than what they would have consumed. So let's calculate that, right? So the question is, if it was given in cash, so their income would be 125, right? Then how much would they have consumed? Okay, so what are the coefficients? 1/4 and 3/4, is that?
Under the cash grant, they will consume 6.2.
Let me do the calculation and I'll tell you exactly. So utility was what? F to the power 1/4.
Yes, sir.
1/4 m to the power
M to the power 3/4. And
Okay.
the prices were 5 and 1. Remember.
Yes. So food price is 5, movies price is 1. So right away, okay. So how much would be their ideal food consumption? It will be 1/4 of 125 times divided by the price of food, which is 5. So 25, 1/4 of 25, which is
6.25.
6.25. And now the in-kind grant is 5 kgs, which is less than this. Okay, so when you have in-kind 5 kgs.
No, sir, I think they're comparing it with the case where there is no cash grant. In that case, the optimal food.
That's not the case to compare to. The question is, there is a situation where cash and in-kind would lead to exactly the same choices, and we are trying to identify whether that is the case or not. Now, if you recall the picture, let me draw the picture again. So this is, let's say, the original budget line, okay? And then we have this 25 rupees, which can be given in cash or kind. Now, if it's given in cash, then we have a parallel shift of the budget line like this, okay? And if it's given in kind, then we have this red budget line, okay? Now, if you recall that discussion, the question is the point of tangency on this, the budget line that will arise on the cash grant, would the point of tangency be here or there, right? So that question refers to this outer budget line, the budget line that will arise if you gave the 25 rupees in cash. And from our calculations, what we see is the kink is at 5 kgs. And if the cash grant was given, then they would have bought 6.25 kgs. So this is the relevant picture. And when the picture is like this, we know that the choice on the red budget line and the choice on the green budget line, namely in kind and cash, are the same. In both cases, they'll choose 6.25. Right? Does that answer the question?
So basically, then they will just have to use their income to consume the extra 1.25.
That's right.
And use the rest of the income on movies, right?
Yeah.
Okay.
Sir, excuse me.
Opposite case, that their consumption was less than what they were getting as in kind. So in that case, they'll be using only the in kind and spend the rest and spend all the money on the movies.
Yes. So in that case, the optimal choice would be basically the point of the kink.
Okay, sir.
Sir, excuse me.
Yeah.
Sir, could we go about like this? If the consumer knows he's getting an in-kind transfer, then we can change his utility function and calculate the optimum with that utility function. Like if if he's getting an in-kind transfer of 16, then his utility would be f plus 16 raised to the power the function which was given. Can we go like this and then calculate the optimum?
Say that again.
Sir, in our case, the utility function, wait a second, sir. In the problem set which we were given in the problem set, the utility function was 1/4 ln f plus 3/4 ln m. So if the consumer knows he's getting an in-kind transfer of 16 kgs, can we change his utility function to 1/4 ln f plus 16 plus 3/4 ln m? Then we could optimize this function with respect to the budget constraint and calculate the optimum f and m. Can we? Because sir, if I do that, then also I'm getting.
Yeah, you can do that, except that you have to be careful about corner solutions, right? For example, when you have this kinked outcome, when the outcome is at this point, you can formulate it the way that you suggested, right? That you put f plus 5 and then decide. But when the relevant picture is this, the optimum choice is at the corner, that means beyond the 5 kgs, they buy nothing. So their own food purchase is 0. So that's a corner solution, okay? So the answer to your question is absolutely fine, except that you have to watch out for corner solutions.
Okay.
So, sir, in his case, what we'll see is the indifference curve will be hitting the y-axis, and the optimum will be over there, since it's 0 amount of food.
Yeah. Yeah.
Okay. Yeah.
So the only danger I see, and there's nothing wrong in the logic, you can throw in that cash in-kind grant into your problem. Just be aware of, just don't rush into this MRS equal to price ratio without looking at it closely.
Okay, sir. So we should look at the kink also. That we should.
Yeah.
Okay, sir. Okay, thank you.
Sir?
Yeah.
Sir, I have a doubt. Sir, we can find the supply function using two formulas. One is the MC is equal to price, and second is the profit maximization, in which we put the labor and capital in the production function in terms of P and the input cost.
Sure.
So in the question will we be given that from which approach we have to find, because the answer in the both cases are different.
If the question is find the supply function, you can use either approach. Anything which is logically correct is fine. But sometimes the question itself asks you something like, when after merger of the two plants, what is the cost function of the monopolist, of this multi-plant monopolist? The other question itself is asking you to take the cost, look at the cost function, find the consolidated cost function. So there you have to answer it that way. But if the question just says, after this merger, the two firms combine to become a monopolist, what is the monopolist supply function? You can take either approach.
Okay, sir. Okay, sir.
How will the answers differ in the two cases? Ideally, should they not be the same, because it's in terms of the output prices and the input prices?
The answer will be the same if you calculate it correctly.
Yes.
Sir, and for finding the Marshallian demand, so we should use Lagrangian only, or MRT, MR is equal to price ratio? Sir, which approach will be better?
If you are short on time, you can jump to MRS equals price ratio. That's okay. If you have time, then write it out more fully.
Using the Lagrangian will be better in solving, scoring more.
Wouldn't hurt. Yeah, but don't worry. If you're trying to do it quickly, it's not going to be a disaster if you skip to MRS equals price ratio, except that, write it that, we know that's the profit maximizing principle, and make sure that the problem doesn't involve a corner solution, because there MRS equals price ratio is not the right condition.
Yes, sir. And also before solving for this, so in order to show the like corner solution doesn't exist. So we need to show the inada condition first and prove that it is convex. So interior solution will exist. Then only we should proceed.
The ideal answer would give some sort of argument why the optimal is not a corner solution. For example, take the Cobb-Douglas case, right? There, the argument is very simple that if you choose 0 for one of the quantities, your utility function takes a 0 value. If you choose any positive vector, strictly positive vector, then your utility function takes a positive number. And so that rules out corner solutions right away. Yes. So some sort of argument would be nice, would make the answer complete, right? Even when
Yes,
the actual solution is interior, the perfect answer would make a case. The case doesn't have to be very, it can be informal, like I said for Cobb-Douglas. Right? It has to be just logical and make sense. That, okay, for this reason, I will focus only on interior solutions because right off the bat, looking at the utility function, I know that corner solutions are ruled out. And then
Okay,
you go ahead to MRS equals price ratio.
Sir, and also can we do it like we can differentiate, like first we find MRS and then we differentiate, partially differentiate with respect to X. If this come out to be negative, then we will say it is a convex function. So convex IC will be there and interior solution. Can we do it
No,
like
convex indifference curve doesn't mean the solution is interior.
So basically, we don't need to like prove the quasi-concavity using the Hessian matrix of the utility function and then go ahead. We don't, right?
It's I mean, rarely do you get a question which has more than 2 goals in the exam. So if it's 2 goals, you have the indifference curve, you can just differentiate to prove that it's convex or concave. Right? You don't get into matrices and all that.
So could we also use the argument that the marginal utility of a particular good is tending to infinity if the quantity of the good is tending to 0?
Yeah.
Okay, sir.
Yeah, that will guarantee that the indifference curves slopes, as you get close to the axis, they become infinity or 0, right? So they're asymptotic with the axis. That immediately implies this interior solution. In response to the previous question, convex indifference curves don't necessarily mean that you can't have corner solutions, right? There are plenty of examples you've seen, I think, in your problem sets. You can have a picture like this. These are convex indifference curves, but the solution is at the corner. So don't make that mistake. It's not sufficient for them to be convex.
So I had a doubt from the problem set 3. Basically, there was a question on the CES production function, and we had to find its elasticity. And then for specific values of the parameter rho, basically we had to say for what value it will become a Cobb-Douglas and linear and all. So I found the solution by equating the elasticities, and for Cobb-Douglas, rho comes out to be infinity. But now if I plug it back into the CES function, I get it to be a constant, like it comes out to be 1 to the power infinity. So I'm not able to understand like conceptually, like, because it's clearly not a Cobb-Douglas then, but then from the elasticity logic, that's the solution that we get. So how do I verify this?
See, it approaches Cobb-Douglas in the limit, right? So there's a little bit of trickiness there with, it's not like, if I recall, it's not like there's a particular parameter value you can plug in and Cobb-Douglas just falls out, right?
So we have to use the indeterminate forms of limit. Like I had to use the L'Hopital rule to get one.
Right. So as a certain parameter approaches a certain value, in the limit, the CS production function approaches Cobb-Douglas, right? It's if you literally plug in that exact value, you end up not getting things that are undefined and so on. So that's I think the catch there.
Got it, sir.
So to calculate the limit, you have to use, as I think Aishwarya said, I think, there are 0 divided by 0. So you have to take L'Hopital's rule and stuff.
We could just add and subtract 1, and we just have to use because it will come out to be an indeterminate limit. So we have to use some method of evaluating it to
Right.
get 1.
Yeah, I find the CES production function annoying, frankly, but it's useful because it encompasses, various different shapes of isocones. So it's very more powerful than the particular forms like Leontief and Cobb-Douglas and so on. They're all nested in the CES production function.
I had another question with regards to problem set for production theory. So question 4, the second part of that question. So we have two different firms, and we require the short run supply curve. So the method that has been used to solve is the simple profit maximizing method. But if I use the 2-step approach of trying to minimize the cost first, I somehow am not able to come to the answer. So could you please explain that question?
Is it coming out like very strange answer in terms of W and R?
It somehow I'm not the solution there is pretty lucid, but if I use the 2-step approach, which I'm more comfortable in, I'm not able to come to the answer.
So you're differentiating the cost function to get into the supply function, right?
Yes, basically yes.
This is problem set 3, I guess.
Yes, sir. Problem set 3, question 4, part 2. This is problem set 4 in my opinion.
Sorry. Problem set 3. Yeah. Number 4.
Number 4, part. So part C, sir. The last one. Yes.
Okay. So you're saying you wanted to?
I wanted to derive the short-run cost function, but like I don't know how I should go about this. What should I minimize?
Okay, let's see.
So I tried to back calculate using the supply function that was found in the solution, and I came to realize that the cost function has the price in it, which makes no sense because the cost function does not have the output price in it. It's with respect to the quantities and the input prices.
Yeah.
Because the supply comes out to be a constant value, √5.
Well, one approach you can take is take an arbitrary K, right? Oh, I see what the problem is. See, once you choose your K, yes, this is why you can't get a combined cost function here. You pick a K here, right? So there's a K and there's a 1 minus K. The outputs are immediately determined. Yes? So
yes.
the cost function presumes that you have flexibility in terms of the total output that you want to create. But you don't have that flexibility in the problem. because of the Leontief form of the production function and the fixed amount of capital, you can't do that. You don't have complete degrees of freedom in terms of how much total output you allocate.
But so we still have to allocate the total capital among the two firms, right? So the output is in terms of a variable K, not a constant. We haven't allocated it yet. We have one unit and we have to divide it. So the allocation is not fixed. In that case, how do we have a quantity, fixed quantity?
Well, at least you have an upper bound on the quantity, right? So K1 minus K. So the Q1 will at most be root over K, and Q2 will at most be 2 times root over 1 minus K. Now, if you use less labor, then labor will become the binding constraint. But you see the problem, right? I mean, when we construct these kind of consolidated cost functions, that assumes that you can create any aggregate quantity that you like. That feature is absent in this problem. Okay? There's an upper bound on how much quantity you can create.
Right, sir. Right. So using the profit maximizing approach is the ideal one
for this particular problem, right? It's not just short run. Short run. So the fixed that factor of production is in fixed supply, but there's still a decision about how to allocate it across the two firms.
Yes. Understood, sir.
Okay. All right. Okay, guys. So all the best. I hope that was somewhat helpful. There's an additional paper which I've posted, as I said. Take a look at that. Also look at the instructions. I mean, sort of for the online format, and be prepared at 1:50 on Monday. That's when the exam is. Okay.
Thank you, sir.
Yes, sir. Thank you, sir. Sir, class was really.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you. All the best, guys.
Thank you, sir.
Yeah. After Monday, you can relax a bit. First batch of exams will be over. So best of luck.